Let's talk neuroplasticity and the freedom to change. Only here on the People Scientist podcast. You are listening to the People Scientist, the podcast dedicated to helping us optimize our health with the latest scientific findings on neuroscience, physiology, and nutrition. I, your host, Dr. Stephanie Caligiuri, a nutritionist, physiologist, and neuroscientist, will be here with you every single week, bringing us information to ignite our thinking, to help us be one step closer to the healthiest we can be. Hello, my People Scientist Army, and welcome back to the People Scientist podcast for episode 151, where I aim to arm us with some scientific information so that we can all become a little bit smarter and a little bit healthier with every new episode. How's your day going so far? Hope it's going well. Whether you are listening before going to bed, on your commute, while at the gym, whatever you're doing, thank you for allowing me to be a part of your day, and I hope that I do not disappoint. So what interesting topic do I have for you today? Well, today I'm going to be discussing with you the concept of neuroplasticity and the freedom to change. This topic is rooted in neuroscience, but it also has a touch of philosophy as well. So in this episode, as I always aim to do, I will share with you some relatable examples, some actionable ideas, and some recent clinical trial evidence. But before we get into this topic, as we always do, let's start off with a foregone fact, where I share scientific finding from long ago. Marion Diamond is the scientist who propelled the field of neuroplasticity forward back in 1970s. She conducted some simple experiments in rats in which she changed their living environment, and she wanted to see if that could alter their brain architecture. So she had a control group where a rat lived alone in a very simple cage. Then the comparator group was a group of 12 rats, all housed together in a very large cage with tons of objects to play with. She had noticed that the rats housed together exhibited, on average, 6% thicker cerebral cortex, as well as dendrites that were longer and had more complex branching, with larger dendritic spines and synapses. She also conducted an experiment when her lab would hold and talk to the rats daily into their older age. She found that those rats lived 50% longer than the other rats that were not held and that were not talked to daily. So back in the 1970s, Marion Diamond's studies were some of the first to illustrate that the environment that an animal or a human is living in can literally change the structure and therefore functioning of the brain, which can therefore impact longevity, behavior, and successful aging. And that in itself was a very empowering concept to know back in the 1970s and something that we're still looking into today. So now, how about we get into the core takeaways of today's topic on the neuroplasticity and freedom to change. Neuroplasticity refers to the brain's ability to change and to adapt. Think of neuroplasticity as our brain having flexibility and adaptability. Now, neuroplasticity can have both beneficial and detrimental effects. Examples include addiction and anxiety, which would alter brain connectivity and behavior in a negative way. Beneficial neuroplasticity can occur during skill acquisition and meditation and exercise, for example. We also understand that hormones can play a role in brain plasticity, influencing the brain's ability to adapt during different life stages. I'm also going to talk about exercise and psychedelics and how they have shown to promote neuroplasticity as well. Now, the brain's adaptability raises the philosophical question about freedom and choice. Does neuroplasticity limit or enhance our freedom? Can we transcend our brain's predispositions through conscious effort? I give some interesting thoughts to ponder in today's episode. How about we get into those scientific details? Let's first talk about what neuroplasticity is. I equate this to our brain being like a garden. A garden can be shaped and transformed, just as a gardener can modify the garden by planting new seeds, removing weeds, and nurturing the plants. Neuroplasticity allows our brain to cultivate new neural connections, to prune the unnecessary connections, and to nourish the growth of healthy brain networks. So neuroplasticity means the ability of the brain to be plastic, which you might initially be thinking, well, that doesn't sound good, our brain being plastic. But what it means is the ability of our brain to have plasticity, meaning the ability of the brain to be flexible, to adapt, to be malleable. The brain can change according to our everyday living situations and according to the choices that we make. And our brain changing can be either a good or a bad thing. So let me give some examples. Upon repeated exposure to addictive drugs like nicotine or opioids, we can see the brain architecture change. Unfortunately, it can change in a way that would perpetuate addiction. This is why addiction is considered a disease of the brain. The brain literally does change so that the quote-unquote safety valves or safety mechanisms that are supposed to tell us to stop consuming a drug, those disintegrate. And I literally see the connections, for example, between the medial habenula and the interpeduncular nucleus in the brain, called the fasciculus retroflexus. I literally see that connection weaken and degenerate upon repeated exposure to drugs like nicotine. And it is speculated that when this degeneration happens between these two brain regions, that aversive protective signal, the one that we should receive when consuming high doses of nicotine, that signal is lost or lessened. And as a result, higher doses of nicotine can be consumed because that safety mechanism is lost. This is an example of a detrimental neuroplastic adaptation of the brain to a lifestyle choice that we may have made. Another detrimental example of neuroplasticity is in relation to anxiety and stress. We understand that there is a connection between two brain regions, for example, the interpeduncular nucleus and the median raphe nucleus. Now, the interpeduncular nucleus is supposed to send an inhibitory signal to the median raphe nucleus that says, hey, quiet down and reduce the level of anxiety that you're feeling. Think of the interpeduncular nucleus of our brain as the safety valve on a water pipe that can slow down or stop the flow of water. But certain things in our life, such as chronic stress, regular intake of alcohol in high amounts, and even hormone levels can influence the connectivity of these two brain regions and can prevent the inhibitory input of the interpeduncular nucleus onto the median raphe nucleus. So to equate that to the analogy, imagine stress, chronic life stress is like rust on a safety valve, preventing the safety valve from working properly. So what I'm getting at is our lifestyle choices or the things that we're exposed to can change the connectivity of two brain regions to potentially increase stress and anxiety even more. It is as though we have broken the safety valve on that water pipe. Now, you may be wondering, how can we even measure the connectivity between brain regions, and how can we measure neuroplasticity? Well, we have techniques such as MAP-seq that we use in preclinical models, and in human studies we have diffusion tensor imaging that allows us to assess the connectivity and neuroplasticity in brain regions. But those were some detrimental neuroplastic changes. How about some beneficial ones? A beneficial neuroplastic adaptation can be seen when learning a new skill, for example. Something most of us can relate to is the skill of driving a car. Or how about as a child learning how to write, learning how to dance? Sometimes we might refer to these things as muscle memory. You ever heard of that phrase? And what muscle memory is really referring to is how the cerebellum of our brain is forming new connections and storing those memories in the cerebellum in order to allow us to be able to perform these physical tasks regularly. Repeated practice and focused attention can strengthen these neural connections that can help us acquire and improve our skills. So now that we appreciate that neuroplasticity of our brain can either be of benefit or detriment to us, what can we do in our everyday to influence the neuroplasticity of our brain? Well, Tang in 2012 conducted a study that illustrated a 4-week program involving meditation induced some neuroplastic changes to the brain. In this study, 113 students underwent either 2 or 4 weeks of integrative body-mind training. or there was a control intervention that involved relaxation. Now, the integrative body-mind training essentially was a form of meditation. It had involved relaxing the body, imagining peaceful scenery with calming music in the background. This method of meditation stressed no effort to control the thoughts in our mind, but instead to have a state of restful alertness that allowed for a high degree of awareness of our body and of our mind. So they had done this practice of meditation in 30-minute increments. Now, in the 2-week group, they did this type of meditation training 10 times, and in the 4-week group, they did this type of training 22 times. So practically, they did meditation for 30 minutes a day, Monday through Friday, with the weekends off. Now, the scientists had used diffusion tensor imaging, which is capable of measuring structural plasticity of the white matter of the brain. And the scientists had measured this at baseline and after the 2 or 4 week intervention of meditation. Now, they had noted that after the 4 weeks of the meditation, they noted an improved efficiency of white matter around the anterior cingulate cortex of the brain and improved measures of mood. However, the 2-week training program resulted in some improvements, but not as significant. So the scientists illustrated a time-dependent benefit of meditative practice on the brain. And this took approximately 4 weeks of 11 hours of total meditation in order to see these physical changes to the architecture and functioning of the white matter of the brain. I personally think that that's quite remarkable, that a 4-week meditative program can literally induce noticeable physical neuroplastic adaptations in the brain, and can also result in enhanced mood and attentive control too. So what else might influence our neuroplasticity or our brain adapting and changing? Laura Bean in the journal Neuroscience and Biobehavioral Reviews in 2022 reviewed how hormones can drive neuroplasticity in our brain adapting. Now, during significant life transitions, our bodies undergo hormonal changes that can affect our brain and our nervous system. And these hormones play a crucial role in preparing us to adapt to these new situations and these new demands. And our hormones can influence our brain's ability to change during those different life stages. Now, although early life and adolescence are well-known critical periods for hormones to exert these neuroplastic effects, hormone-driven neuroplasticity continues throughout our entire lifespan. In particular, we can see these hormonal impacts on our brain during pregnancy and parenthood, in middle age, and to a lesser extent, in older adulthood. But there is evidence that hormone-driven neuroplasticity can drive adaptive behavioral responses to these new environments. So hormones can help our brain adapt to a new environment. This raises the question in my mind then as to how influencing our hormones, such as with oral contraception, for example, particularly during puberty, how that can impact the brain and the neuroplasticity of our brain. Unfortunately, we really don't have a full understanding as to how changing our hormone levels with oral contraceptives, how that can change our brain and the neuroplasticity, and something that really should be investigated further. Changing hormone levels can certainly impact the brain. For example, there's evidence that when female animals experience a decrease in estrogen, that they exhibit certain behaviors that suggest that they are more susceptible to stress, more susceptible to feeling anxiety and depressive-like symptoms. Interestingly, the opposite, high levels of estrogen during late pregnancy, seems to make the animals more resilient. But a sudden drop in estrogen makes them more susceptible to mood disturbances. So low estrogen seems to have a detrimental impact. Higher estrogen seems to be associated with resilience. And I'm curious then if this can help explain potential cause of peripartum depression or postpartum depression. Again, an area that really needs far more attention and research. Now, scientists are still trying to fully understand how estrogen withdrawal or a drop in estrogen can cause this susceptibility to anxiety and depression. But recent studies suggest that a specific brain region called the dorsal raphe nucleus might play an important role here, as this brain region is very sensitive to estrogen and is responsible for producing serotonin, a neurotransmitter that we know impacts mood and emotions. Now, while there is evidence that hormonal fluctuations during the period surrounding childbirth can cause changes in the structure and function of the brain, it is not well understood which of these changes persist beyond that period of postpartum and how long that lasts. Again, proving the point that research on females and women and neurobiology of hormonal fluctuations, it's far behind what is critically vital, and hopefully an area of research that I can contribute to in my own lab soon. So what we do understand is that hormones can change the neuroplasticity of the brain, and part of that is because hormonal fluctuations are in response to our bodies changing and into our environment changing, and as a result is going to help our brain become more plastic and adaptive too. But beyond hormones, is there something within our control that can influence our neuroplasticity? Well, Horto Baggi in 2022 in the journal Aging Research had pooled together 50 different studies with nearly 2,300 people to understand the impact of exercise on brain plasticity. And the scientists in this study suggested that both high-intensity aerobic exercise and resistance training had positive effects on neuroplasticity. They had noted that higher intensity exercise in particular led to greater improvements in neuroplasticity in healthy younger adults. However, even low-intensity exercise still had a significant overall impact on neuroplasticity. Now, the mechanisms as to how exercise can improve neuroplasticity likely involves multiple pathways. For example, aerobic exercise, such as running, walking, cycling, jumping rope, dancing, these can increase blood circulation in the brain and can also promote the clearance of waste products in the brain. While resistance training, like weightlifting, acts through insulin-like growth factor 1 mechanisms in order to influence the brain. These exercise-induced changes can also affect the production of new mitochondria in the brain and in the muscles as well as improve the antioxidant capacity in the muscles and the brain too. And we know that the mitochondria are important in providing energy to our brain, and that dysfunction of mitochondria in the brain is implicated as a cause of dementia. So the fact that exercise may enhance neuroplasticity by positively promoting the production of the mitochondria is an excellent thing. I think that's the reason why a lot of the times exercise is promoted, to promote the resilience and adaptability of the brain. Tart in the journal Molecular Psychiatry in 2022 reviews the importance of neuroplasticity in major depressive disorder. Now, major depressive disorder is a common psychiatric condition characterized by changes in brain structure and function. And the hippocampus is a part of the brain that is known to be involved in mood regulation and memory, and it also appears to be impacted in individuals battling with major depressive disorder. Now, cognitive deficits are also common in major depressive disorder, with abnormalities in brain regions that are responsible for attention and memory. So an inability to focus or having rumination on negative things can be a common symptom, major depressive disorder, and that might be related to the hippocampus of the brain. Now, antidepressant treatments may promote neuroplasticity in the brain in a beneficial way. For example, traditional antidepressants can increase levels of certain neurotransmitters, such as serotonin, in the synaptic cleft of the brain, which could improve network activity, cognition, and behavior. Now, magnetic resonance imaging studies, or MRI studies, provide evidence that antidepressants can prevent volume loss of the hippocampus and can increase gray matter volume. They may also decrease neurotoxicity and promote neurogenesis. Now, rapid-acting antidepressants like ketamine and psychedelics are also showing promise to have a positive impact on neuroplasticity and as a treatment for depression too. So let's get a little bit more into psychedelics. This year, Calder and Hassler published in the journal Neuropsychopharmacology the utility of psychedelics in promoting neuroplasticity. In recent years, there has been a renewed interest in studying psychedelics like LSD, psilocybin, and DMT. Scientists have provided evidence that these substances, when combined with psychotherapy, can have long-lasting positive effects on mental health, even after just a few doses. Now, patients with depression, anxiety disorders, and addiction have reported significant improvement that can last for months or even years. One theory suggests that psychedelics can enhance neuroplasticity, the brain's ability to reorganize its structure and function. Neuroplasticity is crucial for learning, for storing new memories and for us to adapt to new experiences throughout our life. And disruptions in neuroplasticity are often seen in mood disorders and addiction, making neuroplasticity an attractive area of study for promoting mental health. So if it is proven that psychedelics can enhance neuroplasticity, it has made scientists ponder if combining psychedelics with therapy, if that can enhance the effectiveness of therapy. Can psychedelics enhance learning? Can they enhance acquisition of coping skills? Can they enhance retelling of our story in our mind, storing a new memory, pruning the old memories that we don't need anymore, removing them? Can psychedelics help in that therapy session? And can it be an important component to help in the new learning of how to move on forward in one's life? At the molecular level, psychedelics have been found to promote changes in gene and protein expression that are related to synaptic plasticity. And they can also stimulate the growth of synapses and dendrites and can increase synaptic strength. Some studies have shown that psychedelics can enhance neurogenesis, the formation of new neurons, particularly in the hippocampus, that brain region that I had mentioned that seems to be implicated in major depressive disorder. However, it is important to note that the evidence from human studies regarding the impact of psychedelics on neuroplasticity have been mixed. There are markers of neuroplasticity, such as brain-derived neurotrophic factor, but they have not consistently shown significant changes with psychedelics. Now, studies that involve brain imaging have provided some evidence of altered neural connectivity after psychedelic treatment, indicating that psychedelics may have potential neuroplastic changes or induce neuroplastic change. There is a surge of new research being conducted in this area, and I think it really will transform the treatment of mental illness in the near future. So now that we have an understanding of neuroplasticity, this poses an interesting philosophical question. Are we in control of our brain and its neuroplastic changes and therefore our behavior? Or are we just under the control of our brain? I've had this discussion with my brother Ryan a few times, and I love the intersection of neuroscience with philosophy. So let's dive into that a little bit. Now, the philosophy of freedom of choice and the concept of neuroplasticity, I think, intertwine, because freedom of choice encompasses the idea that we can possess the power to make our own decisions, shaping our own lives and influencing our outcomes. So let's ponder whether the plasticity of our brain limits or enhances our freedom. What do you think? Does the brain's adaptability confine us to predetermined patterns? Or does the fact that our brain being adaptable, does it open up infinite possibilities for growth and self-actualization? Can we transcend our predispositions through effort? Or are we forever confined by the limits of our brain? In contemplating these questions, we can delve into the connection between nature and nurture, genetics and environment, and the balance between determinism and free will. Neuroplasticity challenges the notion of predetermined destinies, I think. I think that it suggests that the brain is not fixed in its functions and capabilities, but rather it can evolve throughout our life. This concept of neuroplasticity can open up a world of possibilities. Can we deliberately steer the course of our neuroplasticity? Can we consciously rewire our brain to cultivate positive habits, to acquire new skills, or to reshape our perceptions of the world? The relationship between freedom of choice and neuroplasticity is complex because even though we might possess the freedom to choose, our choices are also influenced by the neural pathways already established in our brains. Our past decisions and experiences can shape our present choices. Maybe our genetics do too, and that could create a web of interconnected causality. Now, the interaction between nature and nurture adds a layer of complexity because it poses the question, are some individuals predisposed to exercise their freedom of choice due to their genetics or their early developmental experiences? And to what extent can the environment impact the adaptability of our brain? For example, let's consider two individuals who grew up in different environments. Let's say one person was raised in a nurturing and supportive family, while the other experienced neglect and adversity. Now, despite their very different upbringings, both of them possess the freedom of choice. However, the neuroplasticity of their brains might have been influenced differently by their early life experiences. The individual from the nurturing environment, maybe they developed a strong sense of self-confidence, with neural pathways that support positive decision-making and being able to follow through and succeed. On the other hand, perhaps the individual who faced adversity might have developed neural pathways that are more attuned to survival and self-preservation. Now, while both individuals we can say have the capacity for change, their starting points and the influences on their neuroplasticity differ significantly. So that raises the question, again, is there freedom of choice or is it partial? They have the ability to change, but their baselines are different. But I think neuroplasticity also offers us hope too. Imagine a person is born with a genetic predisposition for anxiety. They may find themselves frequently experiencing anxious thoughts and feelings which could influence their choices and their actions. However, I think neuroplasticity offers hope because through effort and through therapeutic interventions, they might be able to engage in practices and coping skills that could gradually over time reshape their neural pathways. It could gradually help reduce their feelings of anxiety and cultivate a greater sense of calm and well-being. This example demonstrates how even though genetics and early life experiences may shape our initial neural tendencies, our neuroplastic changes, that the brain also allows for the possibility of transformation and the exercise of freedom of choice in shaping our mental and emotional states. As I often say, and as I learned this statement from Dennis Charney, an expert in resilience, he and I often say that our genetics are not our destiny. I think that our genetics give us a better understanding of ourselves and can sometimes give us a target to better ourselves. But I think overall, understanding that our brain is adaptable is empowering, because that means that the changes that, or the choices that we make in our life have the ability to physically change our brain. And when our brain physically changes, that can change our attitude, our behavior, and our mood too. So I think personally, from a neuroscientist perspective, the fact that our brain is adaptable supports the notion of freedom to change, rather than a predetermined path for us. But what do you think? Do you think that your brain was shaped during your childhood due to your environment and the things you experienced? And do you think then, as a result, that you do or do not have control over your outcomes? Or do you believe that you have the ability to change your brain and therefore your outcomes, and that your outcomes are somewhat in your control today? Now, how we answer this question might be able to provide some insight into our attitude about life and how resilient we are too. So that is a wrap, my people scientist army, an episode intertwining neuroscience and philosophy. Neuroplasticity is our brain's ability to adapt and be flexible. This can be a beneficial or detrimental thing. For example, some neuroplastic changes might put us at a higher risk for mental illness and addiction, or it can help us become smarter, more skilled, and more resilient. Exercise, meditation, learning new skills, and psychedelics are examples of things that have evidence to promote beneficial neuroplastic changes. So because we have this knowledge on how to positively change our brain, is our behavior and our outcomes, are they somewhat in our control? What do you think? What's your opinion on that? I'd love to hear. So thank you for joining me in today's episode. I hope I gave you something interesting to ponder today. If you want to message me or see some of the papers I cite in each episode, then feel free to follow me on social media. My handles are in the description box to this episode. If you by chance want to buy me a coffee to say, hey, thanks for the show, I greatly appreciate that, as I don't accept sponsors or ads to keep this podcast unbiased and uninterrupted as much as possible. The links on how you can show me your support are in the description box too. Now, because in 2 weeks' time it will be Independence Day weekend, I'm going to take that weekend off from the podcast, so you can expect episode 152 in 3 weeks' time on July 9th. Thank you for hanging out with me today, and I look forward to hanging out with you again soon. Bye for now. I am a scientist simply sharing scientific evidence. Some of the clinical interventions I discuss are not appropriate for everyone. Before making any changes to your diet or lifestyle, please do consult the advice of your physician or dietitian. My opinions expressed here do not necessarily reflect those of Mount Sinai Hospital and its affiliates.